Hello everyone, welcome to today's lesson. Today, we will learn about the perimeter and area of rectilinear figures. And the topics in today's chapter are perimeter of rectilinear figures, area, and area of irregular shapes. So let's get started. The perimeter of a rectilinear figure is the sum of the length of all sides of the figure. The units of perimeter are same as that of length, that is centimeter, meters, and kilometers. To understand this better, let's find the perimeter of this sandwich. Here we can see the sandwich is of 3 sides. 2 sides are of the length 12 centimeters and 1 side is of the length 17 centimeter. The sum of all the 3 sides is 41 centimeter. So the perimeter of the sandwich is 41 centimeter. Now, if we have to find the perimeter of a door, we again have to add the length of the 4 sides. We can see that the door is 2 meters on 2 sides and 1 meter on 2 sides. The sum of all the sides is 6 meters. So the perimeter of the door is 6 meters. Perimeter of a rectangle. Now we know in a rectangle, opposite sides are equal. So let's draw a rectangle and find its perimeter. Have a look at this figure. Here is rectangle ABCD. The perimeter of ABCD is AB plus BC plus CD plus DA. Or we can also write this as AB plus CD plus BC plus DA, which equals to 2 into AB plus BC, because AB is equal to CD and BC is equal to DA, since opposite sides of a rectangle are equal. To simplify this, we can write it as 2 times AB plus 2 times BC. So the formula of the perimeter of a rectangle is 2 times or 2 into the sum of its length and breadth. Perimeter of a square. A square is a quadrilateral with all 4 sides equal. So have a look at this figure. Here we have square PQRS. The perimeter of PQRS is PQ plus QR plus RS plus SP, which also equals to 4 into any one side. So the formula of the perimeter of a square is 4 into any one side of the square. To understand this better, have a look at some examples. Now, let's find the perimeter of a rectangle whose length is 15 meters and breadth is 8 meters. Now we know the formula of the perimeter of a rectangle is 2 into length plus breadth, which equals to 2 into 15 plus 8, which equals to 2 into 23, which equals to 46. So the perimeter of the rectangle is 46 meters. Now let's find the perimeter of a square with each side being 60 meters. We know that the formula of the perimeter of a square is 4 into any side of the square. We know that each side is 60 meters. So the perimeter is 4 into 60, which is 240 meters. Now I hope you understood that. Let's test it with an exercise. I'll help you with the first one. Let's find the perimeter of the given figures. In this figure, we can see that there are 4 sides. Sides of 4 cm, 6 cm, 7 cm and 3 cm. When we add all the sides, the final answer is the perimeter of the figure, which is 20 centimeters. Now let's find the perimeter of a triangle PQR with sides PQ equal to 13 centimeter, QR equal to 15 centimeter and RP equal to 18 centimeter. We have to simply add the 3 sides, which is 13 plus 15 plus 18. The perimeter of the triangle PQR is 46 centimeters. Now let's find the perimeter of a rectangle whose length is 35 centimeters and breadth is 19 centimeters. We know that the formula of the perimeter of a rectangle is 2 into length plus breadth, which is 2 into 35 plus 19, which is 2 into 54. So the perimeter of the rectangle is 108 centimeters. Now let's find the perimeter of a square of side 17. The formula of the perimeter of a square is 4 into side of the square, which is 4 into 17, which is 68 centimeters. Now let's do a word problem. The side of a square lawn is 13 meters. We have to find the length of the fence that has to be put around. So we know that the perimeter of a square is equal to 4 into side of the square. The fence that has to be put around it will be 4 into 13, which is 52 centimeters. So we need to put a fence of 52 centimeters around this lawn. Area. So Rohan and Suman both bought chocolates for themselves. They both started arguing over the fact about whose chocolate is bigger. So they opened their chocolate and started counting the number of pieces of chocolate each had. Now, both of the chocolates looked quite similar in size, but Rohan's chocolate had 15 pieces in it, but Suman's chocolate had 16 pieces in it. We can use this idea to measure the size of some other objects. For example, if a tray can fit 25 square burfis, we say that the size of the tray is 25 square units. Area is the amount of surface an object covers. Have a look at this figure. This stamp covers an area of 6 square units. If each square has a side of 1 centimeter, we can say that the stamp has an area of 6 square centimeters. We can write this as 6 square centimeters. I hope you understood that. Let's test it with an exercise. Have a look at this figure. So, how much area does this design cover? We can see that there are 10 squares that this design covers. So, the area of this design is 10 square units. Finding the area of other shapes. Have a look at this shape. This shape covers 8 whole squares and 2 half squares. 2 half squares make up 1 whole square. So, the area of this shape is 8 plus 1, which equals to 9 square units. To understand this better, let's do an exercise. Have a look at this figure. We can see that this figure covers 4 squares and 8 half squares. 8 half squares make up 4 full squares. So the area of this shape is 8 square units. Area of irregular shapes. Now, have a look at this figure. This figure does not have a definite shape, so we can only find the approximate area of this figure. The first step to find the area of this figure would be to count the whole squares. We can see that there are 6 whole squares. Now, we have to count the parts that are half or more than half. Let's mark it with a point. And let's ignore the ones that are less than half a square. We can see that there are 6 parts that are more than half. Let's add the 2 parts, which gives us 12 squares. So the approximate area of the shape is 12 square units. Now, let's go through the summary of today's lesson. Today, we learned about perimeter of rectilinear figures, area, and area of irregular shapes.